Okay, we're continuing our foray into Swing, the one of the three frameworks for creating graphical user interfaces. And so today we're going to address this issue about gracefully exiting, meaning when you close a window, which regardless, on every platform there's like a little button in one of the upper corners that you click on, and then the window shuts down. And now, ultimately, if you have an application where there's some state that's changing, and there's the possibility of saving it, you want to make sure that the user has an opportunity to do that. The next level of that is if there haven't been any changes, then and the user says, I want to exit, then you can just exit that. That's actually a design choice. The thing about user prompts is that it's a bit of a double-edged sword, in the sense that you don't want to be exiting without allowing the user to at least have an option where they might have either accidentally clicked it or clicked it and then a second after. Have you ever clicked on something and then a second after you clicked it, you immediately regretted it? If it hasn't happened to you, it happens to me, and it happens to a lot of people. And so the graceful part is, if that happens, then you give the user one last chance to kind of say, hey, yes, I really want to do this, or no, let's think about it. And then we'll start kind of looking at the different types of components that you can use to create a user interface. Kind of widgets, for some reason, is the term that some people use for this. So, and the book has some nice examples. It's just that there are some things that are not the best practice. So the best practice for doing this kind of thing are to take these widgets, put them into something called a JPanel, and then put the panel on there. And so within these panels, you can create. Typically you'll have multiple panels running around. But now, in order to make the buttons do something, then we're going to need this concept called action. So what's the takeaways? You should be able to sort of gracefully exit, meaning give the user a choice, and then this thing called a JOption pane is what we'll use to do that. That should be fairly straightforward, but it's like code that you have to write. And I hope you're kind of getting the sense that these things don't just sort of happen automatically. They happen because whoever wrote the application made it happen, and that's one of the senses I hope you get out of this. All right, so we're going to implement a user confirmation on the exit attempt. So, and here's the concept to understand, and this is something where this idea is a very important one, and that is that it's event-based programming. We've seen in object-oriented programming that the program consists of different objects that are sending messages to each other by invoking their methods. So if one object wants to send a message to another, it has to have a reference to that object, and it has to invoke a method on that. This event-based interaction is, under the hood, there's some, that's how it's kind of implemented, but conceptually it's a very different idea. The idea is that you have one object that, instead of directly invoking a method on another object. It basically fires an event out uh, into the ether, as it were. And anybody who's listening can kind of respond to it. So, and that's, if maybe you're thinking, okay, what's the difference? Well, there's a big difference. And the main difference is that invoking a method is very tight coupling. In other words, it's like you invoke the method and that bang, that's going to happen. If you fire one of these events and nobody hears it, it's like, does the tree in the forest make a sound? We don't know because nobody heard it. So if you fire an event out and nobody hears it, then nothing happens. Whereas if you invoke a method, then that actually happens. So that's okay. So we're going to look at kind of two of these. There are actually many of these. They're like whenever you move or click the mouse, there are things called mouse events that get triggered. When you type a key, there are key events that occur. The thing is that those are actually very low level types of things. If you're writing a drawing program, then you work with these mouse events, because it's like, what is the user doing? The user when the user kind of drags, what do you want it to do? Do you want it to kind of draw a line? Do you want it to kind of draw a curved line? Do you want it to kind of be creating a shape? All of that, at least in this type of concept, is going to be driven by these window events, mouse events in that case. We're going to deal with just two types. Window events right now, and then action events, which are these kind of more abstract things that are fired by pretty much all the different widgets there. So the idea, all right, so what do we need to do? We need to say, all right, if the user attempts to close the window, we want to sort of catch that and do something with it. And the something is we want to confirm with the user that they really want to do that. That confirmation is going to be using this thing called a JOption pane, which we'll get to in just a second. But first, let's sort of take a look at what this actually is kind of like. Okay, so if you do a pull on the class code stuff, there should now be a package called CS2173 swing. And okay, so here's the thing: is that when you're writing one of these, the usual way to do business is to extend JFrame. So the JFrame is the swings window that does that, and then the things that you want to put in that and how you want it to operate, you want to put those in there. And okay, so once you do that, now this is just a class. We're writing a class, and so it's just going to be like any other thing. So it has a constructor. So here I'm extending JFrame. I'm calling it my frame, whatever you call it. Now here I'm exploiting the constructor. One of JFrame's constructors has a string that's the title. So here I'm just going to say super. You should know what this does. So super, that calls the superclass constructor, the JFrame constructor, with an argument of a string. There's no red squiggly, which means that there must be such a constructor. There are actually a number of different constructors, but that's the one we'll have. Now, so here's the thing. Remember that there are 4 different options for when you close one of these JFrames. There was hide on close, which is the default, which keeps it running. There's dispose on close, which kind of basically gets rid of that object but keeps the program running. There's exit on close, which means that when you close the window, the whole program shuts down. And as we saw, that, and we'll actually see here because we're going to kind of override that. But what we want to do is we actually want to do nothing on close by default, because when a user tries to close it, we don't necessarily want to close it. Okay, so that means that we have to say we want to do nothing on close. Right, now the other thing is that typically what we want to do is we want to instantiate all the different widgets that are going to be in this window. And one standard practice is to have like a private or possibly protected helper method. So instead of kind of littering the constructor with all the stuff, we just call I call it init for initialize, and it's a private. So that means that nobody else I don't want anybody else to have access to this, but this is how we're going to create things. So here I'm just doing I'm creating the JPanel that I'm going to use to put my widgets in. And here I'm just going to create a button. I'll call it an exit button. And it's going to say exit, and I'm going to put it into the exit panel. And notice I'm adding it to the north element of the border layout. Remember, in the border layout, they had these 5 different areas. There was a big block in the center. There were kind of 2 skinny ones up top, and then 2 skinny ones on the side. So the north one, I'm going to add it there. And then to run it, do a couple things. So first, I'm going to instantiate it. And then notice that since it's subclasses JFrame, I can actually declare it to be a JFrame. If for some reason there were other methods or other settings that I wanted the user to be able to invoke here, I would have to declare it to actually be a myFrame. But here I don't. Now there are 2 options for this, and I want to say if you don't do this, by the way, if you don't set the size, the default size is like 0 by 0, and so you get this little tiny thing, which is pretty useless. So you always need to kind of set the size, and ideally the location. If you don't set the location, the default is the origin, and remember the origin is the upper left corner of the screen, and so usually things kind of appear more in the middle. There's actually a way to center your window. We don't have to worry about that yet. I'll probably have a chance to kind of show how to do that. It just requires a few extra little invocations. All right, now just because we haven't set it up yet, I'm going to override. Notice over here I said I do nothing on close. Well, while I'm, so the first test. Because I haven't set that up yet, I'm going to override that and say, okay, I'm going to exit on close just so I don't have to kind of do some extra things going on. Okay, and that should really display it. Now here's the final thing, and this is something that this is one of my issues with the book. This or something like it is really a preferred way of running this. There are a couple options, like actually NetBeans lets you kind of use one of these. I can convert it into one of these guys. I don't really like that. Okay, so what's going on here? First of all, this event queue, this is the graphics thread, and what you want to make sure that all of your graphics elements are on the graphics thread. Invoking this method setVisible, that will make the frame visible regardless of which thread it's on. But if it's not on the graphics thread, then problems happen. We don't need to kind of go into what they are. But this is the way to do it. The event queue, this has a method called invokeLater, and what it wants is a runnable. Remember when we were talking about threads, we know what a runnable is. Okay, but we don't really have a runnable. So here's what we can do with inner classes. Remember, we were talking about inner classes, and in every other instance except this, it's preferable to have a named inner class. In fact, we're going to define a named inner class. Hopefully, I'll get to it. But here, this is an anonymous inner class defined inside of a method. Okay, so now that is generally a bad idea, but in this particular case, it's really the cleanest way to do things. So as you notice a new runnable. You can't instantiate an interface. But what you can do is you can kind of create a class on the fly that implements that interface. That's what we're doing here. We're saying we're creating a new runnable. What does it require to create a runnable class? I need to implement the method. Just in general, you can do this for any interface, but it's not a good idea. What I want to do is I want to have the set visible on the frame on the graphics thread. And the way to do it is to put it as an argument to this invoke later method. Now the other option, and I think I did this with the previous one, the other option is that I could declare this class to implement runnable, have the run method be kind of out here, and then have the frame itself be a static variable, and that's fine too. You know, just this is a little less overhead. You know, this anyway. So that's important. So what does this look like? Okay, so I have so here's the title that I have, and then okay, here's a little exit button, and okay, when you see a button, you sort of click on it and you expect the button to kind of do a little flash that says you've clicked it. Okay, it does that, and it doesn't do anything. And because I've overridden the exit, when I hit it, it kind of blows out. Okay, so now what I want to do is I want to now sort of capture that. So I want to do away with this. So if I do away with that, and let's see, okay, so see now if I run it and I do this, say, remember it said do nothing on close. I'm clicking this, and now it does nothing, which is what I want, except now I have no way of closing it other than to kind of go in here and blow the thing out. Right, so now how do I do that? Whenever, despite the fact that nothing was happening, let me show this again, even though it looked like nothing was happening, when I clicked this little circle here, it was actually firing a window closing event. Okay, so that's the key to doing this. So I'm going to write a new class that's going to handle what happens when I try to do that, and I'll call it a window closer. And I want to implement an event called a window listener. Notice there are a couple of, so window listener as the interface. Okay, so window listener. Notice that it's Java AW. So even though AWT is kind of that was the original one that's not recommended anymore. Nevertheless, Swing is still kind of very much dependent on some of the classes and stuff in there. All right, so now got a red squiggly here. We're not abstract, so we want to implement all the abstract methods. And we see that there are all these different abstract methods we have, and they're well named. Window opened, what do you like whenever you open a window, you have a window closing. That's the one we want. Window closed, so window closing is before it closes, and then window close is when it actually does close. Window iconified, iconify is when you kind of make it small. So whenever that happens, it fires an event. De-iconified, whenever you bring it back, deactivated. So the window listener interface requires all of these different methods. And that's a lot of stuff, but I only care about this one. So what they've done is they've written a very nice, very cute little class. This is one of my favorite classes. It's called Window Adapter. And what Window Adapter does is it implements all of these window listener methods and doesn't do anything. So if I only want one, then what I can do is I can just delete all the ones that I don't want. Okay, and I don't get a window a squiggly because this window adapter, in fact, we can even take a look at what it is like. It's an abstract class, but notice that it implements all of these different events, methods, but doesn't do anything with what's called a no-op. Okay, so this window closing is the one I want. So when I try to close the window, I'm going to grab it here. So here's what I'm going to do is, now what do you expect? I expect a little dialog to pop up and says, hey, are you sure? All right, so now how do I do that? There's something called a J-option pane. J-option pane. And there are a lot of there are a lot of different ones. The one that I want is show confirmed dialog, and it's expecting a bunch of stuff. So it wants the parent component. What this is this is the message, and so let's see. The message I want to send is, do you really want to exit? And then the title on the little thing, I'm going to say confirm exit. Now there's a type, and unfortunately the people who wrote these are fond of these magic ints, and there's a magic int here called I want the OK cancel option. In other words, I think by default it gives you 3 options. I only want 2. Now the last little bit here is the parent component. I need to get the parent component. And how do I do that? I can do that by okay, so let's kind of unpack this a little bit. When I attempt to close the window, that's when I click on that red thing, it's going to fire a window event, and actually on window closing. So it's going to actually kind of call, if I'm listening, it's going to invoke this event. And that event tells me what window it is. And the reason this is important, I could actually put null here, but what you expect when you get a dialog is that it, so for example, like even here, like if I want to open something, see a little dialog pops up. This is actually I'm not sure what the exact class of this is, but notice it kind of appears in front of this, and it's actually a modal dialog because it doesn't let me do anything else until I dismiss this. Okay, so that's what this is going to create. Now, so let's, okay, where are we here? So one of the things that I want to do with that is in here. I'll instantiate it, and then I add it as add window listener, not window focus listener, add window listener, this thing. And so now, okay, it's still not going to work the way I want it yet, but let's sort of just see what happens. Let's make sure it's sort of hooked up. Now when I try to exit it, it pops up here. It says, this is the title I gave it, confirm exit, and I say, do I really want to exit? Now, if I say yes, it still doesn't do anything. Okay, so now what happened? Well, I need to do a little bit more. So, when that shows up, the user says either okay or cancel. Okay, and you've seen this a million times. You know, you get a little dialogue, okay, cancel. What do you expect to happen? If it cancels, says you do nothing. If you say okay, then you want to do the thing. So how do we do this? With a magic int, unfortunately. So with this dialog, it returns an int called, that we can capture. I'm going to call it user input. And then I can test it. If the user input is equal to, and then, now which one do I want? And I don't know what the value is, but I want, if the user says okay, then I want to exit. And I can exit by calling system exit, and I want to pass it an argument. The reason for this is, this actually kind of goes back to Unix days, is that when you're running a program, it always returns an integer. And if it returns 0, that means the program exited correctly. And if it returns any other number, then that means that there was some kind of error. You could get that number and figure out what the error was based on how the user, how the programmer wrote it. Okay, so now when I run it, when I click on this, okay, do I really want to exit? Okay, I'll say cancel, make sure that happens, that nothing happens. And now, if I really want to exit, then, okay, what the heck happened? It should exit. Do I really want to exit? Yes. Okay, why? I must have screwed up something. Add window listener, window closer. So, now that is, this is what happens when I, let's see what was going on there. All right. What the heck happened? If user input, all right, this is ridiculous. That is bizarre because it does not. If user input is equal to, that's what it's. All right, let me see. Zero. All right. Come on. This is really, is it not a, what do you mean it's not a known variable? All right, so how did I screw this up? This is really bizarre. This has never happened. Closing. For crying out freaking loud. Not a known variable. What the? We're right here in the for crying out loud. How can it say it is not a known variable? It is right there. It says it's not a known variable. This is so bizarre. I mean, okay, yeah. Well, let me try calling it something else. In all the years that I've been doing this, this has never happened. Crap. All right, well, all right, well, I'm gonna have to move on. I don't know what the hell is wrong with that. But, all right, let's let's do buttons. This is insane. Um, all right. So the way buttons work is our main thing we're going to work with is a J button. That's what we had there. But there are also other types of buttons. It turns out that a menu item is a button. We're all used to menus. And then there's something called check boxes and radio buttons. You know what those are? Okay, so a check box is when you can have multiple things to check, and a radio button is when you get to pick one out of a set. You know why they're called radio buttons? Generational thing. Back in the day, car radios, the way that you set on the car radio, the way you set the station that you listen to, they literally had these push button things, and you would set them, and when you pushed one, then so if one was pushed down, then all the others would be popped up, and if you pushed another one down, that would pop up. That's why they're called radio buttons. So anyway. Okay, so the expectation when you click a button, something is supposed to happen. And as we've seen, by itself, the J button has that experience. So you click on it, it flashed a little bit. When it's clicked, the J buttons actually, they fire a number of different events. They don't fire window events. One of the main events they fire is called an action event, and we can use something called an action listener to listen to that. So let me have no idea why that was not working, but I'm gonna have to kind of go back to this for that. All right, so let's so here's how we set that up. Let's just do a little. Okay, let's create another J button. I'm just going to call it click me, just to show it's sort of clicked. And let's add it to the panel. And now what I'm going to do is I'm going to add another J label. And I'm going to call it sort of a status. And I'm going to add that to, I'm going to get the content pane. This is one of my contentions with the book. The book just sort of slaps stuff onto the frame, which you can do, but you shouldn't. You should always put stuff in the content pane. And in this case, I'm going to put it down south. All right, so let's see what that looks like. Okay, so there's my status down here, and here's my click me here. Okay, we still have this business. All right, now, how do you make a button go live? That's where this action listener comes in, and there are a number of different ways of doing it. The worst way is to actually create these anonymous inner classes and hook them up on the spot, kind of the way we did over here with this. But that is the worst way to do it. The second worst way to do it is the way the book does, where we kind of create these classes outside. But here, what I want to happen is that when I click on a button, I want the status to reflect which button I clicked. So to do that, in my opinion, the best way to do it is with a named inner class. And I want to make it private because I don't want anybody else to deal with it. And I'll call it a button listener. And there's a interface called Action Listener. And red squiggly says implement all of the abstract methods. It has one abstract method. So these lightweight interfaces, like Action Listener, is you see how it's a lot more lightweight than that window listener, which had a bazillion different methods. This just has one. And so what I want to do here is I just want to I want to update the status label based upon what happened. So first of all, I want to, okay, I'll do it. Okay, this is a little bit. Now, unfortunately, the action event has a method called getSource, and that where are you? Here. Unfortunately, it returns an object. It could have returned something a little bit more informative, like the window event returned the window. But this just returns an object, which means if I want to do anything interesting with it, I have to cast it. So I'm going to cast it to a J button because that, and actually, if, tell you what, let's okay, so I'll go with abstract button just in case I want to listen to other types of things. And then what I'm going to do is I'm going to set the now I can't now notice the scope issue here. So here I defined my JLabel to be a local method, a local variable in the init method, but I want other access to it. So I want to make it now an instance variable. And I don't want to make sure I do that. Now I can set the text to what that is. Okay, remember all my rantings about scope. So previously, when status was a local variable in the method, then only that method had access to it. Here, I wanted this method to have access to it, and so I needed to kind of expand its scope a little bit, in this case to an instance variable. Now, the other thing about scope here to notice is that this is an inner class, and inside the inner class there's yet a method. Nevertheless, notice it has access to the instance variables. So basically everything inside the class has access to all the stuff. So now what this is going to do is so if okay, it doesn't do anything yet. Why doesn't it do anything? Because I haven't made it do anything. Where are we here? So what do I have to do? I have to instantiate it, and then add it as an action listener. Okay. Let's spell it right. Okay, so now, when I click it, you see that the status changed. And in fact, what I can do is, without even doing anything more, I can even have it listen to the action. Oops, not you. You. So now if I hit exit, so whatever, okay, what it's doing is whatever the text was in that component, it was writing in the status. So now it's like, okay, notice that I'm actually doing something here. But that's not really what I want the exit button to do. What I want the exit button to do is actually do something like what I was trying to do here. And so what I can do, remember, we can implement multiple interfaces, and as long as we, oops, action listener, and then I want to, illegal start. Oops, yeah, nothing. There. Now we want to implement all the abstract methods. Gives me an action performed here as well. Okay, now let's see if maybe it works better with this. This should show confirmed dialog. And I have to do a little bit more work to get the parent component. And then all right, now for the parent component, what I need to do a little bit more work here. So there's a thing called swing utilities. Get the root of and then I'll be unsafe. Okay, so what I'm doing is what do you want? Do you want a component? Okay, so the swing utilities has a thing, if I give it a component, it will get the root, and that's what I want to give it for this. And so, if I go back to this, I can now add the action listener to that. So that same window closer thing is a dessert topping and a floor wax. It's a window listener and an action listener. And then if this, see if this has any more luck with this. Let's so this is still working here. All right, now for some reason it worked for that. Why didn't it work for this? I don't know. Now, I don't see any difference in these. All right. Now, the thing is, I mean, here's the problem with this, is that I'm doing the same thing. I mean, I don't know why this one didn't work. Notice that this one did work. What's the difference between them? I have no idea. Basically doing the same thing. However, here, these two bits of code are almost identical, and that is not a good thing. In other words, when you, if you have two different ways of doing the same operation, then you want to guarantee that you're going to get exactly the same thing. And here, I can't guarantee that. You see why I can't guarantee that? Whenever you have two different sets of code that are invoked, then Murphy's Law says they're going to get out of sync. And so if I go to close things, it should be exactly the same. In other words, I want exactly the same code to be executed regardless of which way I do this. And so next time I'll show you what's going on with that, and hopefully you've figured out why this stupid thing didn't work. But just to just one last thing. This actually worked for that. So it's like, what the hell?